We will be starting in a few minutes. A few more people join the stream. Okay, so message the chat. Write something in the chat if you can hear me and if you can see me. Just say hi. Ayub is ready. Hi. Hello Anna and hello C-Spence 1010. Can you guys still see my video? Oh. Is my video frozen? Hello Armin Bugramian. Armin, you can still see my video? Okay, it's fixed. Perfect. So let's jump right into it. My name is Jacques. I have a master's in computer science. I'm an ex-Google software engineer. I'm the previous head of education at a university bootcamp. And I'm a programming instructor. My passion is to educate people about coding and programming. I'm the creator of Wakata. We'll be talking about Wakata in a few minutes. Does anyone have any questions about Google or my work experience or my education before we jump into the content? You can ask me anything you want. If you have a question, put it in the chat. Okay, let's jump right into it. You please ask me questions as often as you can. It makes the live stream more enjoyable. And if you have a question, other people might have the same question. So, let's talk about the elephant in the room. So, to date, I've taught many students to overcome the elephant in the room when it comes to becoming a developer. That no matter how advanced you think you are at coding, unless you train your brain to think like a computer, you will never have what it takes to write beautiful code. And you'll run into a lot of problems, both in the context of your individual projects and your professional career. What do I mean by training your brain to think like a computer, especially as it relates to JavaScript? Well, I'm talking about understanding exactly how a computer, which has a brain that's quite different from the mind of a human being, interprets JavaScript code and other programming languages. I'm talking about what actually happens inside the brain, also known as random access memory, of a computer when it reads your code. Anna writes, do we have a recording after? YouTube automatically records. So you'll have a link to the video at the end. For some of you, it's frozen. So, why I'm here today, a very specific purpose. I'll explain much more about this as we proceed through the workshop today, but for now, I want you to know that I've created an online learning platform called Wakata, which has been thoroughly vetted by the 100 or so students who attended my in-person coding bootcamp in Montreal, Canada, that teaches you this crucial skill of how to think like a computer. Full disclosure, I'm going to be honest with you here. I want you to turn you into a believer that there's a better way to becoming a developer. Wakata, by the way, means I understood in Japanese. I first launched it in the summer of 2018, and I keep improving it and releasing new tools within the platform to help its users become even more masterful developers. By the end of this workshop, it's my goal to make you clearly see that my unique method of teaching you about coding, which is housed inside the Wakata platform, is the solution to the horrible problem that has infected our industry and that is doing a massive disservice to everyone who aspires to be a programmer someday. The typical way of learning to be a developer is broken, and that it fails everyone with a genuine desire to becoming a proficient coder. I'd like to hear a little bit about your experiences and your struggles becoming a developer. So has it been an easy road for you, or have you run into many challenges along the way? Please write in the chat, and I will be managing this session. Jonathan Guzman writes, I say it has been challenging. Well, Jonathan, you're not alone. Many people find learning software development very challenging. So let's see what we can do about this. Jonathan writes, I think learning how to learn effectively was the toughest for me, if that makes sense. Josiane writes, I'm a newbie and trying to figure out how to go about it. Well, let's try attacking Ayub writes, my challenge is to build a valuable portfolio of projects as a beginner. Armin writes, it's been interesting but hard to focus on a couple of subjects and not spread all over. Maximiliano Tosca writes, it's a continuous process, never ends. There's always something new to learn. So let's see what the big problem is in learning how to code. Let's explore a bit more as to what I mean by the current becoming a developer system being completely broken. It seems a little arrogant of me to say that, after all, but it's the truth. You have all these brick and mortar universities and colleges out there, all these in-depth courses, boot camps, and other resources online, and even though all these people are putting a huge amount of effort into educating their students, everyone is doing it wrong. And I'm not the only person who thinks this. It's actually an open secret in the teaching research community. For example, Dr. Jenkins writes, at the moment, the way in which programming is taught and learned is fundamentally broken. The paper he wrote this in was cited over 700 times, which indicates that many people agree with him. And the results are not very encouraging. A basic programming task was given to 216 students after the first year of computer science. The average score was 21%. That is not okay. That is why I created Wakata. This abysmal average score points to the fact that something very big is missing in the curriculum for computer science programs. It's common knowledge that the so-called fundamentals are the most important part of being a software developer, but no one is teaching the actual fundamentals to students. There's an absolutely critical body of knowledge that is entirely ignored by virtually everyone who professes to be able to teach the code. And this is a serious, tragic problem. This body of knowledge, whose importance nobody seems to clue into, is how a computer's brain operates, and what we need to do to communicate effectively with its brain. Does anyone in the audience sometimes code and not actually understand what's going on? Are you often surprised by what the computer does based on what you write? Please write something in the comment. Josiane Dennis writes, yes, sometimes. This is a common problem among beginners, and as a teacher, I've seen my students struggle to actually understand how a computer interprets code. What do I mean by this? Allow me to explain. We write code to communicate with computers. There are two types of things that we can do when we communicate. Number one, we can tell a computer to do an action, such as display an image or play sound or communicate with another computer. But there's another aspect to communicating with a computer that is so much more important and so poorly understood. That's the aspect of coding that involves giving the computer information that will alter its memory. For example, via code, you could tell a computer, I live in Montreal, the grass is green, the name of my mother is the same as the name of a famous rock star singer, etc. What you're doing here is modifying the computer's memory. When you're a developer, for every line of code you write, you should be asking yourself, how does this modify the computer's memory? Because that's the only way you're going to truly understand what's happening inside the computer's brain and be able to write reliable and effective code. But this question doesn't even enter people's minds. Sure, they might end up learning it implicitly after years of practice, but there will still be erroneous assumptions. You'll get an approximate understanding of how a computer's memory is modified, but there will be gaps. So the way you'll handle coding is by engaging in a lot of trial and error, which is obviously tedious and frustrating, and won't get you good results. You're going to miss many opportunities to write beautiful code because you're just hacking your way through it. And if you manage to land a job as a developer, you might regularly miss deadlines or get poor reviews, or even get fired because your boss will realize how deep down you just don't get it. Is it frozen for anyone? Alina writes, yes, it's frozen for me. Let's continue on. When I was teaching at Concordia boot camps, I had many students who, by the end of their training, did not get some very important fundamentals. And this posed an existential crisis for me. I was very worried about their future as software developers. Even though I was trying different things, I was taking different material to try and really hammer in this fundamental knowledge, I just wasn't able to get to them. The reason is that people have a preconceived notion of how things work. It's impossible to tell someone all this stuff you think you know is wrong. Please try to think differently. Unfortunately, many students come with very large misconceptions about how programs interpret code. So my big insight is that I realized that people needed a different way to learn. This is where my Wakata platform comes in to save the day. I've created a tool called CompuThink, which is the first tool you interact with when you sign up for Wakata, that allows you to visually see how code modifies the computer's memory step by step. By showing you this visually with true immediacy, you quickly begin to grasp how the code you're writing alters the brain of a computer, which allows you to stop playing internal guessing games when you're writing or debugging code. This has an incredible positive effect on your ability to write reliably, get a computer to do what you want it to do, which is the whole point of being a programmer. Rather than leaning on your intuition, which operates according to the erroneous assumption that the human mind and the brain of a computer work the same way when you're coding, you'll actually be able to switch over to an alternate way of thinking, which is defined by thinking exactly the way that a computer does. It puts you in a position to become one of the best developers out there, in a sea of so-called developers who actually have no idea what they're doing. When I shared CompuThink with my students, they finally got it. It was amazing. The kinds of questions I was being asked before and after my students used CompuThink were like night and day. I started to have faith in their futures again, and I knew I was onto something big. Today, after many of my students have used CompuThink and the other tools inside Wakata to hone their coding skills and land fantastic development jobs on the very first interview, I know that this is the new way of learning to code. This new way of learning to code has played a huge role in fixing that glaring problem that exists within our industry. Most devs don't understand how to think like a computer, that all we need to do is train our brains to think this way if we want to position ourselves for the best possible degree of success in the software development world. I'm excited to share CompuThink with you today as a powerful introduction to the Wakata platform, so you can start to empower yourself with the skill set that is so painfully absent in all other learn-to-code opportunities that exist out there today. Recently, researchers have gone out in the field and started to catalog the misconceptions that students have. A paper in 2018 identified 40 common misconceptions. No one is addressing these problems, and the status quo is terrifying. Students failing to solve easy problems because of a lack of understanding. Students deserve better. Let me demonstrate with one simple example. But first, a little bit of a review. I have a computer program on the left-hand side of the screen. And this computer program prints 3 to the screen. Programmers say that the output of this program is 3. There's a variable declaration followed by console log. The console log is what displays the number 3 onto the console. My question to you is, what is the output of this program? Jonathan Guzman writes 1. Or possibly undefined. Ksenia writes 4. Tommy writes 4. Good guess, Jonathan, but the answer is actually 4. So A originally refers to 3. Oh, Josiane writes 3. There is a line right here, A equals A plus 1. So the variable A goes from 3 to 4. When you console log it, it is 4. Here is another question. I've replaced the last line from A to B. And I want you to give me the output of this new program. So this is a brand new question. So Jonathan, Tommy, and Sabrina all answered 3. Armin also, and A. Before I give you the correct solution, Josiane writes 4. Okay, so I'm getting different answers. Some people think it is 3. Some people think it is 4. Before I give you the answer, let me tell you how most beginners look at this problem. Most absolute beginners think about this problem. They see that a is equal to a plus 1, therefore a must be equal to 4. Then they see b equals a, therefore b must be equal to 4. Since a is 4 and b equals a, therefore b equals 4. So when you console log b, you console log 4. This is absolutely incorrect. However, this is what we learn in mathematics class in high school. I'll now present you the correct way of thinking about it. Here I have the code on the top left of the screen, and I will animate exactly how a computer interprets that code. In the middle of the screen you have computer memory. Every line of code is called a statement, and statements modify computer memory. So let's go ahead and simulate how computer memory gets modified by the code. We see here that as far as the computer is concerned, a and b are different variables, and there is no relationship between those two variables. They are modified independently of each other. When we did a equals a plus 1, we only modified the variable a, not the variable b. Therefore, when you console log b, you actually console logged 3. Let's look at another topic, objects, which are also very much misunderstood, but once you understand how a computer interprets objects, it becomes straightforward and much easier to understand. So I have an example program right here, 2 lines of code. On the first line I have an object with the property foo. Then let x equals that object literal. The second line of console.log x.foo. Since x has a property foo with a value of 2, x.foo evaluates to 2. So the output of this program is 2. Here I have another program which is actually similar to what we were doing before. My question to you is, what is the output of this program? Please put your answer in the chat. Sabrina writes 2. Xenia writes 2. Josiane writes 2. So we saw in the last example that x and y are independent variables. X and y are independent variables. This is absolutely true. However, modifying x.foo does modify y.foo. So let's see an example of that. So in the middle, there's the computer memory. On the left-hand side, we have the variables. On the right-hand side, we have the objects. And let's see how variables and objects are related. First, we create an object with a property foo. With a value of 2. Then we create a variable x. That will refer to this object. Then we will create a variable y that refers to the same object. We will modify that object. So the key point here is that we modified the object, not the variable. And that both variables refer to the same object. So the answer is 3. Not 2, 3. When I present this example to even experienced programmers, they tell me it's because of the difference between a primitive and a reference. This explanation is not accurate. The accurate explanation is that we modified an object. We modify the property of an object. You modify a property of an object using this syntax. Dot foo equals. Since x and y refer to the same object, x.foo will always be equal to y.foo. The key insight here is that objects are like houses. Houses don't have names, they have addresses. Similarly, an object also has an address. X and y are variables that contain the same address. Objects don't have names. Variables have names. I'm going to repeat that because that is a common misconception among beginners, that objects have names. They don't. They contain addresses, and these addresses are the addresses of the object. Referring to the example we just saw, x and y are variables, and they contain the same address, which is the address of this object right here. Any questions? Let's move on to the next topic. In this code, we have 3 lines, x equals 5, y equals 5. Then we'll console log x equals 5, x equals y. Since x and y both contain the number 5, we will console log true. Here is another computer program, and I want you to tell me what the output of this program is, based on what we just saw. Josiane writes, y 3 equals. In this case, 3 equals is the same as 2 equals. So I could have just as easily written x equals y. 3 equals is preferred over 2 equals. But 99% of the time, they are the same. You should just get in the habit of writing 3 equals. Jonathan writes, false. Tommy, Ksenia, Armin all agree that it's false. And the answer is false. Let's see it using the animation. We created two variables x and y. And finally, we modified the variable y. We are not modifying the variable x, therefore, we're going to console log false. Here is another computer program. We have two variable declarations. At the end, we are asking ourselves, is x equals y? What do you think the answer to this question is? Please write it out in the chat. Armin writes, true. Josiane writes, true. Tommy writes, false? Question mark. Ksenia writes, false. And the answer is false, but let's see why it's false. So we create an object. And we create another object. We will console log false because each of these variables, as Jonathan writes, contains a different reference. They contain different addresses. And because they contain different addresses, they are not equal. So the answer is false. So the key point here is that a variable does not contain an object, it contains an address. You can also say that it contains a reference. The word reference and the word address actually mean the same thing. Let's do a little review of functions. So here I have on this slide a function f. And f takes its input and multiplies it by 4, and that's going to be its output. So f of 10 is 40, and when you console log f of 10, you will get 40 as the output. I'm using here arrow notation, but it is equivalent to normal function notation. So I could have written this function as function f of a return, there's a little typo on my slides. I could have used a function notation instead of arrow notation, but in the end, they are the same. So here I have a function g. This is something, and I'm console logging g of 10. Now my question to you is, what is the name of the function? Tommy writes G. Question mark? G? I'll be answering this question at the end of the slides. But this question is trickier than it looks. Jonathan writes, no name anonymous function. We'll see what the answer is. Just be a little patient. So I want you to tell me what the output of this program is. Can you guys read the program and tell me how a computer would interpret it? Tommy writes 12. Sonia writes 12. And that is indeed the answer. Oops. The answer is 12. Here is a slightly trickier example. I have two variable declarations and two functions. I want you to tell me what the output of this code is. Is it going to be 12 or is it going to be 14? Cuts out a little on the left. Ah, yes. Jonathan writes 12. So let's see the answer to this question. Armin also writes 12 question mark, right? So it's not super clear. So we're going to create a function and a variable that's going to refer to that function. We'll create another variable g with a reference to the same function. Now f is going to refer to another function, and then we will call the function that g refers to, which is the function that starts on line number 1. And at the end, we have number 12. So the key insight that I wanted to convey here is that functions are like houses. Houses don't have names, houses have an address. A function has an address. F and G are variables that contain that address, otherwise known as that reference. I'm trying to say that all functions are anonymous. Functions don't have names. Variables have names. The previous slides, I asked what is the name of this function, and the answer is functions don't have names. So it doesn't have a name. So you might ask yourself, is this true for other programming languages? And what I've said in all these slides applies to every programming language except for C and C++. So it applies to Python, it applies to Ruby, it applies to Java, it applies to Rust, it applies to Scala. All of them. Racket, Clojure, all the programming languages. All work the same way. So it's really important to understand how a computer reads JavaScript, because it reads JavaScript in almost the same way that it reads all the other programming languages. So for the remainder of this session, I will be, it's more of a interactive portion. So I want you to go to this link that I posted in the chat and do the Wakata exercises. If you have any questions, you can click on share link and post it in the chat, and I will answer them. If you have any other questions about any of the material I covered today, just ask in the chat and I will gladly explain it to you. So you can ask me about programming in general, about my career, about teaching, about boot camps, about universities. Any question you have about programming or anything related to education, just ask me in the chat. Jonathan Guzman writes, I can't continue as guest in Wakata's site. Let me verify that right now. Oh yes, we have a problem. We have technical difficulties at the moment. Let's take a 10-minute break and I will fix it very quickly. So go ahead and take a 10-minute break and I'll fix this bug shortly. Turns out the link was wrong. I've posted the new link in the chat and also in the slide. So the link is /stream/CompuThink. Jonathan writes, just a question on scope. Would the exercises where you're reassigning values be different if you're using var, const, instead of let? The answer is no, Jonathan. Const will not let you reassign. So in that respect, yes. Const is different because reassignment is impossible. Var and let are the same when it comes to reassignment. So you get the same result in all these exercises if you were to replace let with var. That being said, you should never use let. You should never use var. Always use let. Thank you for participating in today's stream. If you would like to get updates about what I'm up to, you can follow me on Instagram. There's a link in the chat. I also have a Discord channel for anyone who wants to ask questions about programming or about Wokata or anything. The link is also in the chat. And I hope that this workshop has helped you understand programming a little more deeply and that it will help you become a better developer. Have yourself a nice day, and I hope to someday be able to teach you something again.